So first of all, thank you for being a part of this summit, and I would like to thank the jury members who gave me a chance to speak in this forum. Been speaking at the last, has its own pros and cons. Firstly, that all the audience, they are familiar with the terminology used with the SDV, ECU. But the downside of that is somewhere they correlate that this is a part of presentation 1, presentation 2, right? In Hindi we call kahin ki eat, kahin ka roda, Bhanumati ne kumba joda. Right? Basically making something tangible from a standard pieces, right? So, but today I will be speaking on evolution of connected cars and the challenges from the QualDev perspective. So by QualDev I mean most about quality, like testing. So the reason we have clubbed QualDev in some testing systems, so there needs to be better than the production. I will come that to later. So have you ever someone on the testing background and testing field in this audience? Good. So so what's prejudice that we are the testing system? They are low scale as compared to production. Yes, but here I will show you the testing systems that need to be better than the production. So I am myself Karun. I have 17 years of experience in software testing. So I'm working with Aeris Communication India as a QualDev director. So Aeris is a startup basically which develops the apps for the OEMs. We stores the data for the OEMs in the cloud for the analytics. We perform the analytics and we share the user data on the demand. And we also share that data with the different, I would say, industry verticals like insurance, legal authorities. Right? So we sell the data to them. And so it's a startup, but it is funded by SoftBank and AT&T. So firstly, to talk about what's the innovation. So process of developing and implementing new ideas, that brings a significant advancement. We call that as an innovation. Now, but when do we innovate? That's a big question. So there's a proverb necessity is the mother of invention. So all the use cases, the innovation features that I will be talking about in the connected cars, so that has some problem use case with it, right? So there's a business use case which needs to be solved for ease out the user experience, for better user experience. And some innovation features, they are like lifesavers for us, right? So I will cover the. So we talked about a lot of industries which have gone through the I would say major transformation in the last few decades. So I have picked for example the banking industry for the example. So I do remember my father filling the pay slips. Then come the era of the checkbooks. Eventually the ATM comes, so which removed the dependency of the bank, right? So bank on a bank holiday, I can just go and withdraw the money. Although in the demonetization, the ATM failed as well. But now we have moved to the era of internet banking, right? So innovation, right? So I just need an internet, my smartphone or a laptop to make the business transaction. So the automobile industry is also not left behind when we talk about the innovation. Right from the invention of the wheel to the chariot to the car, now we have entered into the world of EVs, right? So this is one dimension. If you look at the innovation, that my engine power is generating, I'm able to drive more faster. The other dimension is more about innovation is connected cars. So I do remember in 90s, 91 or 92. Kapil Dev gave an ad of a shoes action silencer. So, so the catching theme was, क्या जूते भी सांस लेते हैं, right? So क्या गाड़ियाँ भी बात करती हैं? Yes, the cars do talk, right? So what are connected cars? So a vehicle which can connect to the internet is called a connected car, right? So it can connect to the internet via the WLAN, right? And it can play a role of hotspot to the devices inside the car as well as outside the car. So in the North India, the one of big expressway, which also internet at this point of time, so it's a very common thing, right? But if you remember a few years back, I'm not going far behind, when a highway was launched in North India, Yamuna Expressway, that used to connect Greater Noida to Agra. So the selling point of the government was it has access of internet throughout the highway. Even if you're driving at 120, 130 km per hour, you will have the access to the internet, right? And so that's and also in Delhi, 10 years back, the manifesto of Aam Aadmi Party, they gave the free internet, right? So internet is although once you have, you feel things taken for granted if you have it, but eventually it's still very important. And a connected car can play a role of hotspot to the devices inside the car as well as the outside the car. And it can share the data with the external parties. By the external parties, we mean telecom towers, right? It is able to send the data, receive the data, right? And we use the internet to configure the vehicle, to control the vehicle and upgrade the software. So these are three dimensions. I will cover that one in detail. And as I mentioned, we can download the data on the user demand. If I have to see that what is my driving pattern, what's the average of my car, what's the mileage history, what's the charging history, right? I should be able to download that data. So telematics, so what is telematics? A remote measuring is called a telematics, right? So if I'm sitting here, I want to measure something outside, so I would say telematics. So telematics was started in early 90s when GPS signals was measured with the cellular network. So I'm monitoring the location over here, right? So that's a telematics. So we look like the segments of the car, and this is a device, so IVC, or you can call it as a communication unit, ECU, TCU, which is connected to the, I would say, to the internet. It's communicating to the telecom towers. So the data which is transmitted is called upstream. The data which is received back is called a downstream signal. All the data that is sent to the storage part, right? So it is stored for the data, whether that's relevant or irrelevant, that's a secondary, but data is getting stored. And eventually I do have 3 different segments. One is like a mobile app, as I mentioned, basically to control the vehicle. The second, I have for the admin part, I have basically the web interface, where me as a parent, I can restrict the boundary of my car so that my kid, they don't enter into the highway zone, right? And the last but not the least, as I mentioned in innovation, the emergency part, the lifesaver. We have emergency 911 contact. So the call center will call you directly in case of some emergency. So the operations. So the different operations that we can do in connected cars. So I will bifurcate into 3 high-level categories. The first one is the configuration. So by configuration means when a vehicle is produced, OEM is developed, right? Eventually that goes to the dealer, right? And the dealer sells it to the end user, right? But now since we are talking about the vehicles communicating, it's not only the user's identity which needs to be preserved, it's the vehicle's identity which needs to be preserved as well. So the vehicle, the OEM manufacturers, so they send the data, vehicle data to us, right? So if you watch closely, once you go apply for a loan, right, and right side of the window, there's a metal plate of every car, right? That has a engine number, chassis number, everything, right? So that's a uniqueness of the car, right? But now since we are talking about the software, what the OEM does, they send the feed to us. This is the new vehicle that's we have shipped to the dealer. Please process it for subsequent. When the user will purchase that vehicle, we'll get the user details, I would say unique user details, the unique vehicle details. We'll map that and we'll preserve it somewhere in the cloud, in the data. And tomorrow, the user number 2, he should not be able to control the car 1, right? So basically, that's where the data is very important. The second part, the control and the health check. We have a remote charge scheduling, right? So as earlier, one of the speaker mentioned, if everyone comes to the home and they charge the vehicle at the same time, say 6 p.m., there's a lot of, I would say, spike to the power sector. So we can even schedule based on electricity, timing, right? Whenever you want to charge your vehicle, you can schedule. Remote door lock and lock, you can perform the RO operations right from your app, okay? Remote horn, I can play the horn of the vehicle from the app itself. So I will cover each and every use case later. Remote light, I can switch on and off the lights. Remote climate and cryogenic, right? So by cryogenic is basically a winter terminology. So I can in the peak of the winters, I can control the climate of the chassis, of the cabin. Then the garage control. So in the garage control, I don't have to step out of the car. I can manage the garage directly from my app, right? The parental control. So again, as I mentioned, I don't want my kid to enter to a defined boundary. I want to, in Hindi, call Lakshman Rekha. I want to draw a Lakshman Rekha for them. You are learning, you are a beginner, don't cross the limit. Vital status and health check, right? Now I don't need a mechanic, basically, for monitoring the health of the vehicle. My app is suffice enough to give me all the details. Stolen vehicle assistance, right? So basically, if my vehicle is stolen, so I need an assistance. Again, the technology will help me, right? So where it is going as of now, which last MNO tower it communicated to, so everything is preserved in the data. E-call, that's an emergency call. In case of emergency, the call center will call me, and based on my help, my need, so they will assist me. Upgrade, eventually the most important, so there are different dimensions to the upgrade. Eventually it's like update over the software, over the air. So it further I would say dimensions like MOTA. You have to like update the maps, right? So, and we have FOTA, right? Services, SOTA, the services as well. So everything is there, but high level, we should treat that as an upgrade over the OTA. So now coming to like the different use case and why the invention happened, what the problems every feature is solving. Remote lock and unlock. So first one, basically I'm the locking and unlocking the doors from my home. Suppose I come down after the office, I go to my apartment, I forgot. Did I lock the car? So does it happen? It happens with me, right? So then I don't have to like step down to the basement. I just can use my app and lock and unlock the car. So you can see here, right? Basically, when you unlock, right? So the doors will open. You can see the status of the door. Once they are already unlocked, you can press the lock button, and eventually, yes, the lock request is sent to the OEM. Then the remote light. So basically, when we have to like find a vehicle in the mall parking, like wherein my key fob is out of the range, right? That's not working, right? So I can use this feature. So I can switch on the light, right, just to see. Yeah, now the most important one of the most, I would say innovation, the remote climate and cryogenic. So basically I can set a temperature to a normal range prior to onboarding the car. So like in North India, in peak of summers, like May, June, once you enter into the car, right, it's very, very hot because of the glass house effect and the greenhouse effect, right? It gives you a physiotherapy free of cost, right? So to have a better onboarding experience, you can set the climate, like 10 minutes, I will be onboarding the car. Hey, please set the climate properly to my car, right? And similarly, in the EVs, right, you cannot directly like press the ignition on button and drive, right? Eventually, it needs a bit of warm up, right? So to have my driving pleasure, I can heat the EV without, in fact, onboarding the car. From the app itself, I can heat my EV, right? And the cryogenic, in like the countries which are close to North Pole, like Canada, America, right? So they have even in the peak of winter, the temperature going in -20, -15 degrees Celsius, right? So here what can happen, that once I onboard the car, if the temperature is like below -15, it will turn on the ignition, it will turn on the heater for me for 10 minutes. Once I onboard, I will never get an experience that there's something like chilly weather outside, right? The next is a car finder. So basically, again, the use case is you're not able to locate the car where it is parked, okay? So again, it has two dimensions. One, you can blow the horn once you are nearby to the car, or you can track the location. Eventually, your vehicle has the SIM, it has the location. And eventually, like the two locations, it will detect you the pathfinder. If you press this location, it will give you like how many what's the distance between you and your vehicle. The next one, the parental controls. Basically, so it again has three different subcategories. The first one is the geofence alert. So where I get the automated notifications when the kids cross the defined boundary, right? So this is a parental control. You can see like curfew, like speed alert, right? Geofence alert. So when so here my kids, they can't cheat me. Dad, I'm just going 2 kilometers like to meet my friend, right? I can track everything from the app. The speed alert, I get the automated notifications when the kids or my chauffeur overspeeds. The curfew alert, we get the notification when the vehicle enters the curfew zone. So to give you a real example of this, in Delhi, in the peak of winters, to curb the pollution, the government implements the policy of odd and even. On odd days, only the odd vehicle is allowed to enter the premises. On the even dates, the even vehicle is allowed. Suppose I'm having an odd vehicle and I forget the date, right? So to avoid that human error, I can set this into my app. As soon as that will enter the, I would say no entry zone, it will give me alert, come back. Another is like stolen vehicle assistance. Like basically, this is where when my vehicle is a theft, to control the theft, right? So once this is enabled, firstly the all ROs are disabled. Whatever the operations that I have talked so far, they will get disabled. Now only the call center can track the vehicle, and they will help the legal authorities in tracking the vehicles. Vehicle status report. Again, so as I mentioned, I don't need now mechanic to see the health check of my vehicle. the app itself is sufficient to give me all the information, right? I get the information of the doors, lights, fuel, battery, mileage tracker, charging history, and the MIL, that's a malform indication letter, is my engine oil up to the mark, is my tire pressure up to the mark, or is my brake oil up to the mark. Everything the app will tell it to you. And the garage control, basically, I'm able to manage the garage doors while sitting inside the car via the app, right? So eventually the use case is automated garage control as soon as I mentioned, the identity of the vehicle is known to us, right? And I can map that to the device at the garage doors that only the legitimate vehicle which comes to the close to the garage door will open, right? So here we are not like, I would say, providing any facility or service for the garage control, we are just sending the signals, right? So there are like companies in US like Chamberlain, right? So they will give you a device, they will install you at the garage doors, so automatic garage, the doors will open and the car will come nearby to that region. And yes, the most important in case of emergency, the emergency call. Right, so again, it has a different use case. The first one is the emergency. My driver or passenger got some medical emergency. So there's a button in the car at the top of the roof. You just have to press this, and in the IVI, you will see this feature getting enabled. So you will get a call from the call center. If you're not able to, if you're not in incommunicado mode via the IVI, right, they will call you on mobile. So they will assist you with the nearest ambulance, with the nearest hospital, and automatic collision detection. Eventually, as soon as the accident happens, right, so you'll get a call center to the ambulance, right? Just see there's an accident happen nearby, just see is everything fine or not. Although you will also get a call. And the roadside assistance, if I'm like driving and in the late night, right, my vehicle broke down. Okay, I don't have to worry that now how the mechanic will come. I just have to reach to this make emergency call, and they will provide a mechanic. So whatever the use case that I've covered so far, so again, they were like basic, but few like advanced use case, which again are need of the hour today. So I will cover that one now. So as I mentioned, now we are entering into the era of EVs, and the earlier speakers said, so why the people, they are like, I would say, hesitant in buying an EV, right? So the, one of the dimension was that the charging, I would say the infrastructure in India, so that's not well equipped. But the other dimensions to it as well, that me as a, I would say, orthodox mentality man, the petrol tank fill and the diesel tank fill, so it takes me only 2 minutes to fill the petrol or diesel tank. But to charge the EV in the long, I would say, drive, right? So that will again depends not only about my battery status of my car, but also what's the rush or how many people are already in queue who are waiting to charge the car. Eventually my trip duration, so that's a bit dimension. So how the apps and the technology will help is, we can find the charging stations nearby, first of all. And the most important, we'll get the real-time status of the charging stations. How many cars that already there? How many cars they are like in the queue? And the last but not least, the charging cost as well. In India, like we are more of private, I would say, players competing into this market, right? And also the PSUs, the BHEL is there to provide you, to give you the EV charging stations. We have a Tata Power, right? But everyone has a different charging cost, right? So you should not be surprised that after like charging, like that this is your bill. Eventually, like every state has its own fuel cost. Every power provider has its own charging cost. The 360-degree camera, so as we all know, so we have like camera which covers the 360-degree dimension everywhere, right? So with this technology, now we are working on a feature with someone hitting the car or vehicle getting stolen, as soon as it will click the capture instantly and transmit to the owners. So we are working on this project. It's about, I would say, 75 to 80% complete. As soon as it detects something, I would say, a notorious activity, it will click the pictures by using all the cameras. And the data will be like sent to the owner. And one of the, again, important, I would say, feature that we are working is SRP, that's a smart route planner. Imagine that tomorrow you have to plan a trip with your family. Suppose you're going from Bengaluru to Hyderabad, right? And you open your app, you instruct the app that I want a trip from Bengaluru to Hyderabad from this time to this time, right? It will fetch the details, right? It will see it will find you the best route, and apart from the route, it will push that all the route to the IVI, and it will show the nearby restaurants, right? The charging stations, everything. Now you don't have to like search from the scratch again, right? So everything will be there in your IVA system, right? Once you're on the trip. This one, another important, but it's a region specific, I would say, but sooner, like it will be like coming in India, I'm sure, that ISA, Intelligent Speed Assistance. So in Europe, like we have a like ISA system which will be mandated from 2024, right? A function, this would be like when someone exceeds the speed, right? So there's a separate device with additional to IVC or IVI, we have a like ISA box, okay? So it will send, it will give an audible warning to the chauffeur, or will give a sensory feedback on the accelerator, the pedal. Hey, cool down, you're overspeeding. If you still don't ignore that warning, your data will be transmitted directly to the legal authorities and you will be like penalized instantly, right? And but basically the speed information is also transmitted from the ISA bots to the onboard ECU. And we have talked about connected cars, right? But connected cars is not sufficient. We have a connected bikes, we have a connected trucks, so even every vehicle, so that is eventually moving towards the connected ones. And just to let you know, we are working on one of the project in Japan where we have a connected postal vehicles, right? So today, for example, if you courier from like Bangalore to Delhi, right, what information you get that you have shipped to Bangalore, it has like, I would say cleared from Bangalore, it is, in 2 days you will get information, it has reached Delhi, then it has reached the destination. But with the postal vans getting connected, you will get the, as a user, you will get the real-time information where the vehicle is there. And another advantage of this is that with every, I would say, vehicle being, I would say, smart or connected, right? So in case of a collision, right? So there's no illusion, right? So which two vehicles collided? And with the camera, whose mistake, right? So all these things will be ease once the technology is adopted. And the other, like the usage of vital data in other industries, so whatever like I taught so far is basically in terms of, I would say, ease or the features, but the data that we are capturing, so that data we sell to the different industries, right? And how the different industry like leverage that data. So first one is the insurance, right? So the insurance company, they determine the appropriate plans and premium by detecting the driving patterns, okay? So if I'm driving rash, right? So obviously my premium will be high as compared to someone who's driving very, following the rules, abiding the red light traffic, right? So the US company, they buys this data from us. And, and soon you will see the same like a concept in India as well, right? Because in government portal, it shows you how many challans you are pending, right? So, but that data, there's a like discussion going on. Sooner that will be mapped to the insurance when you go for a renewal of a car insurance. So that will be mapped. And we provide the precise data number of accidents done by the driver, right? So, but there is one catch over here, right? Sometimes we will most of the times we'll get the owner, right, who owns the car. But someone, my friend is driving on my car and he made some mistake. Eventually, I will be penalized. So this has some like caveat to it, right? But eventually, so this is industry is looking on to it. And I do remember when there was Shark Tank, a guy who had done a prototype. Eventually, he has one device installed on the steering wheel that will detect the the breath of the driver, whether the driver is under the influence of alcohol or not. You imagine that eventually, if he or she is under influence of alcohol and driving, right? So then the license might be cancelled. Okay, so the data is helping everything. The data used by legal authorities, the tracking presence of car in the past dates for verifying the illibis. Some crime has happened. So we see like most of the like crime shows that we so eventually it ends to the fact the police, they're tracking the cell phone, okay? But now so soon you will see that in our India as well, we have like fast tag. The government can track where I moved, but now with this connected cars, they can even track to which village I went. But it must have communicated to my telecom tower, the vital right signals, and this will help ease in solving the hit and run cases. And the same data, like we can use like sharing the driving history over the car sharing platforms, like Turo and Zipcar. Eventually, if I'm like adopting a car sharing, right? I should be like aware when I'm onboarding a car with the driver. So what's the track record? How much risk I'm taking? How much accident the driver has done in the past, right? So that data is eventually. So currently, if I onboard a Ola or Uber, I just see the rating of the driver, just on his behavior, his driving, but I don't know, right? Is he coming from some hit and run cases? But eventually, with the technology, with this data, this will eventually start coming into the all these apps. So far, like we have covered like all the use cases, advanced use cases, but everything has its own challenge, right? So the challenges, one from the industry perspective, there could be other challenges from the validation perspective. So the first challenge is we have a limited OEM and the standardization, as discussed when one of the speaker earlier, that the standardization is missing. But what we mean about limited OEMs? So how many OEMs there exist globally? If we talk about Maruti, Hyundai, Volkswagen, BMW, Tesla, Audi, right? If I count maximum 20, 25, 30 globally, right? But in India, how many bands are there? If we include the PSU, so it will be more than 30, 35. And globally, how many bands? In 1,000. Of me as a company, if I have to like get a OEM project and I get in a banking project or a healthcare project, so peeping into this industry is very, very tough. Industry is very small. Secondly, the standardization is still evolving, right? Every communication message, every OEM, so they are communicating as per the data as per their own life. There's no standard, right? So the reason I'm telling is because if we are like app manufacturers, if we say we have an app for vendor A, OEM A, can we use that, complete the data and the algorithms for the OEM B? The answer is no, because there is no standardization. We still have to do the same work of parsing the data, showing the relevant data to the like end user. And once the standardization becomes like, I would say, adopted, the development, the pace will be much, much, much faster. So these are the industry challenges, but now I'm covering more of QualDev challenges. So imagine that you bid for a project, you get the project. Okay, so what will first thing we do? We'll make a test plan at high level. Like we'll do API testing, we'll do the functional testing, we'll do the performance testing, with the security vulnerability audits. That's what we do. Okay, but you are not the only one into the game, right? So there are like the cases. We have a communication team. We have a IVA, that's infotainment team. We have like apps for some high level. Although I've kept this as a traditional waterfall, although everyone will have their own agile processes for delivery. So all the requirement, but eventually they all have to communicate for that end user to have a seamless experience, right? So what happens is, eventually you do the requirement, dev testing for the communication, so this could be like IVC, this could be TCU, this could be VCU. And for the infotainment, again the same, the requirement analysis, the development and the testing. Same for the apps, right? We have to do the backend and developmental testing, and this onboard testing. This testing is done by the OEM themselves. Okay, so no matter how how many test coverage, how many test cases that you do, the onboard testing, they will test everything from their viewpoint, and they need at least I would say 5 to 6 months to do this testing. So the dates are hard, I would say. Eventually they have SOP dates, the start of production date, where the vitals will move towards the production line and assembly will start. Okay, any delay or any window squeeze in this onboard testing, SOP will delay it, right? And that will have a big impact. But sometimes, or in most of the times, the occasional cases, once you are developing, you find that this, I would say, handshake communication is not happening with the IVI, this is not happening with the IVC. So what happens is, the testing gets overlapped with the onboard testing. And here, the quality becomes a big challenge, right? Because as I mentioned, the hard dates are freezed, you can't change the date, the SOP date change, eventually the complete, you have to give answerable to even to the countries, the government, everyone, right? So the minimum, I would say, delay will be 6 to 9 months, right? So the dates are more or less freezed. But you have to, eventually when your window is getting squeezed, you have to ensure that your test quality is still enough to meet the guidelines. So this is a very big challenge. Another challenge is that we don't have a non-availability of the car to test all the test cases, right? So we have bench. So first one, what is a bench? So bench is, I would say, a combination of a hardware and a software which emulates the car, right? And we talked about the SDV. So we have a simulator. Right? So we have a code written to mock the vehicle requests and the response, right? And as in the earlier session, the industry is heading towards the SDV with the softwares on the cloud and on the vehicle to emulate the vehicle. But still, no matter how early you start the testing with the simulator, you get the bench, right? Eventually, still you need the few cases to be executed on the car itself. For example, The test cases that can't be tested on the simulator because it's only the software, right? The offline RO. So what's the offline RO? Basically, once you offboard your car, you switch the ignition off, the vehicle is in sleeping mode. Okay, if we have to perform the RO, so it will not work directly. So you have to first wake up your car. How that will happen? Your SIM provider, like Airtel, Vodafone, they will wake up your car, right? So eventually, so here now the MNO is coming into the picture. So this is completely a code base. So this is not possible. Again, the OTA and the MOTA, you need to have the real, I would say, hardware. So simulator is not possible. Few cases that are even not possible on the bench as well. For example, the charging or the violations, the speed alerts. Here you need a real car only to test. Another challenge is for you, so we from India, so basically in onshore offshore model, what we think is like if we win a project, for example, in Japan, right? And we want to set up a testing team in India, right, with the benches. So that's not very straightforward, right? Because every country has its own MNOs. MNOs like mobile network operators, right? So you need every IVC or IVI that you do will emit the signals. You need to take the government approvals before setting up a bench for that OEM. Right? Basically, they need the radio law certification from country government to set up a bench in different country. And setting up a bench in India or remote location is not straightforward as it needs a government consent. Right? So whenever you are bidding for a project, so keep these factors in your mind. Another challenge is diversification. Right? So there are a lot of dimensions to it. So the top three which I have like factored in, the vital platforms. But the platform, like you see the chases, like your IVC, IVI, so everything factors into the one like platform. The mid-size OEM, they have 3 to 4 platforms. A large OEM, they have even 10 platforms as well. Like we have a flavors. By flavors, we mean the different models. Like for example, the Tata, we have a Nexon, Harrier, Safari, right? So, and another domain is country, right? The same vehicle, for example, Mitsubishi. So they are giving services in America and Canada and Japan. In America and Canada, they need the feature of cryogenic, but in Japan, there's no winters as such, right? So they don't need that features. So with all this, like I would say, diversification, the permutation and combination of tests, that's like multifold, right? So, so I would say the coverage becomes a very challenge in that defined time frame. So the regression is indeed very, very challenging. And another like challenge is the replicating the defect corner case. Right, so there's no direct interaction with the customer. Okay, we are sitting in India. Someone says that I have paid for this service, but this service is not working for me. The user is one in a million, but since he's a paid user, he can sue in the law. Okay, so the replication is indeed very, very tough. Right, so you only have the logs to parse and reduce the user workflow. Right, so so you have to like write your like code not only in terms of the behavior point of view, in terms of logging as point of view, so that we can get the complete the story, the operations the user is performing. Now the performance testing, another dimension which like I would say is very, very challenging. So in performance, the first thing that we have a mammoth request for performance, right? So we have approximately 20K concurrent requests that is for mid-size OEMs. So if you talk about the Maruti, it will be in lakhs, 3 to 4 lakhs. Okay, concurrent means at the same time. If you talk about the day, the transaction will be in millions. And the high volume of messages, 20 billion messages exchanged per month. This is a mid-size OEM, right? So that data is getting stored into your cloud, right? With high volume of data storage, right? So the test data generation, so that is very challenging. So what, when you talk about some other industries, say e-commerce industry, so what I need is, I would say the user and the devices that the user search, maybe say LCDs, smartphones. The test data generation is very easy. But here, as I mentioned, firstly the vital needs to be bootstrapped, the authentication, right? So, and how that is bootstrapped, the OEM shares us the feed in the form of XML or the JSON. We process that feed, and then that feed is mapped to the user and the mobile number, the unique mobile number. So the performance test data generation, right, basically is very, very challenging. And the challenge over here is, anyone who has bidded in the testing project, when you like bid for a project, you keep some portion for the performance testing. Anyone? Okay. So basically when you bid for a project, high level, you do a functional testing, performance testing, security testing. The test data you keep, the performance testing is usually 10% of the overall project, and the test data generation is 1% of that 10%. But here what I will tell you, when the OEMs, they give the like bootstrap data, they give that in a staggered way. 1,000, 1,500, 2,000 vehicles sent to the dealers on a daily basis. But in a staggered way, slowly and gradually, when they connect to your cloud, they reach in millions. But once you have to test and certify, you have to like make the data in the millions. In production, if my data, like I would say bootstrap data is able to handle 1,000 OEMs, I would say bootstrapping, that is, I would say excellent. But in performance, if I have to like replicate the millions to see the future behavior, right? My test servers, my algorithms needs to be much better than the production. That's why I talked about the QualDev. It's not only quality alone, right? So you have to do that complete test data generation in 2 weeks, the millions of data. Eventually in the production, that data will come in years, but you have to do it in 2 weeks. The data caching, so that is also another dimension which need to look at. Eventually, so a user A, who is like basically doing the RO, using the vehicle on a daily basis, compared to user B, who really like drives the vehicle, right? So eventually we have to cache the data of the user who's frequently driving. And the dynamic workload model based on the country and the month. This is another dimension only applicable to this automotive industry. In country, when it comes to Christmas, right, you will see a different load from America and Canada. Right? When in Japan, they had a golden week at 10 days back, the vacations. So a lot of load coming from Japan, right? So your performance testing, you can't certify that my system is like performance certifiable. You will have a different workload model on a country and on a month. And on cryogenic, eventually, in the winters, 99% of the requests, they are related to climate only, 99. People say we are okay if my remote light, remote horn are not working, but my cryogenic feature, my climate should be working. Security testing. So this is an important again dimension or challenge from the QualDev perspective. So we all do like, we have to do the VA scans, we have to do the static code analysis, we have to do the pen test, and the most important, we have to get the region-specific cybersecurity go-ahead. So in the Europe, like there's a regulation, a UN regulation number 155, which talks about the cybersecurity of the vehicle. So far in India, we talk about the cybersecurity of the user, but there they are talking about the cybersecurity of the vehicles, right? So how many of you have watched the Fast and Furious movie 8? So there the car is completely hacked, okay? Eventually the drivers, eventually the end is only the accident. So to avoid that, eventually you have to give the certificate, you have to obtain the certificate. No matter how much good your performance is, how much rich your features are, if you are failing on this end dimension, the government will not allow you to launch your cars. And we have the like different KPIs. Basically, once every OEM, so the expectations for OEMs are very, very high, very steep. They want a very high service availability and continuity despite the constant changes coming up, right? So they want to say, you apply this feature for the Japan region, apply this feature for the US region, but not at no downtime. Okay, they want the continuity and availability every time. This is a very, I would say, challenge. And they want the tracking and storing the RO data in production. If tomorrow, like, what's the percentage of ROs which are getting failed? As I mentioned in the like offline RO, first we have to do a wake up, right? And the wake up, the MNO comes into the picture, right? And there could be a scenario where the MNO signals are weak. Someone tries to do an offline RO. So whether that's a part of a like warning message or error message, even that bifurcation is very, very important. By the end of the month, the OEM will ask how many ROs failed because even the MNO signals were up to the mark, and how many MNO signals were weak when the user get the warning message. So everything is just getting tracked, so that's what the expectations from the OEMs, right? And last but not the least, I would say, thank you and be patient. And I hope the session was interesting. Any questions? Mic, please.
I just want to share a couple of unique connected vehicle test cases that may be of importance to you, and I would like to know how we can address that. So we are working with one of the US government in the state of Ohio. They want to approach this in 3 unique cases. One is if a vehicle ends up in an accident, They want, if a vehicle ends up in an accident,
Okay.
right? The vehicle previous to that,
Pardon?
right? The vehicles that are previous to that, that are before that, right? They had to be redirected to a different traffic.
Okay.
So the traffic department has to wants to know very early so that they can redeploy the traffic control, that they can reroute to a different destination, okay, different route.
Okay.
Rather. So what they want is they're asking us if they can work with the dashcam companies to build an AI that can detect an accident and quickly communicate to the nearest police department.
So,
That's one thing. I'll tell you the remaining two things, related things.
Okay, let me answer this first one.
Yeah.
So we are working, so far the feature which I mentioned is ACN, the collision notification. We are working on one of the more feature, that is AACN, Advanced Automatic Collision Notification. As soon as something the two vehicles, they come very close to each other, the airbags, everything gets alerted, right? So that the accident is about to happen. And when the accident happens between the two vehicles, if they both are connected, the data will be stored in the back end, and then the call center will have the access to that data. Now, what we can build over it is eventually, then the accident has already happened. We can since the MNO, we know the location of the accident, precise location, right? So we can just send an alert, something like via the geofence alert, which I mentioned, the alert to the other nearby drivers that there's an accident happened. Please take a different route. We have the data, we can do, but currently we are not doing it.
So this is one case.
Yeah.
The other unique case of importance to you is, say, for example, there's a vehicle has stopped somewhere, and there is an airbag deployment happened. And there is a connection between agreement with the OEMs that whenever a vehicle has a deployment of the airbags, information goes to the OEM. So they want to do a triaging of the data that goes to OEM with the surrounding information to make sure whether it was a false positive or was it really an accident.
Yeah, so this is I would say the technology, I would say the AI detection, everything has a boon and a bane. Right, so the false signal can only, a false positive, false negative can only be basically seen after you have a I would say quantum of data, right? If only there is one false negative, but 999 are correct, we'll don't quantify that as a false negative, right? Eventually, so again, we are also analyzing the data, but so far, we are relying completely on the IVC. They are sending us that the accident has happened, and we are just storing it. Yeah. But over the time, when we'll analyze the data, we'll see what's the preciseness of that trigger signals.
Okay. Similar thing, but not directly connected. A very interesting use case. So what they said is, sometimes in US, flooding happens.
What happens?
Flooding.
Okay.
The rains, suddenly there's a rapid flood.
Yeah.
So they want to know if a vehicle can detect that through the dashcam or whatever, and quickly again communicate that with the traffic department. At least they want to send warning to the other vehicles.
Yeah, so we have not built this feature so far, so but maybe if the OEMs want, so there's definitely I would say a valid use case. So probably, but things again, as I mentioned, so necessity is the mother of innovation. So there's a use case, so definitely it can be solved. Okay. But we are not solving it as of now.
Thanks.